Have you ever wondered if you could travel through time, not just space? Could you visit the dinosaurs or see the distant future? Is time travel possible or just a fantasy from movies and books? On screen, a hero steps into a machine and vanishes into another era. But reality is far more complex and fascinating. Science fiction gives us iconic machines like the DeLorean or the TARDIS, but these are inventions for storytelling, not science. Science plays by the rules of physics, not imagination. Scientists start with mathematics and observation, not cool gadgets. When we ask if time travel is possible, we must look to the universe itself. The universe speaks in the language of gravity, light, and energy. Its answers are rarely simple, but always profound. To understand time travel, we must understand the fabric of reality. Time is not a rigid river. It can bend, stretch, and flow differently for different observers. The universe is stranger than it seems, and the possibility of time travel is woven into that strangeness. So let's leave fiction behind for a moment. What do the laws of nature actually allow? We'll explore the ideas of the greatest minds in history. We'll see how time is far more mysterious than we once thought. It can bend, it can stretch, it can flow at different speeds for different observers. The universe is a far stranger place than our everyday experience suggests, and the possibility of time travel is woven into that strangeness. Let's begin our journey. To understand time, we must talk about Albert Einstein. He showed us that space and time are woven together into a four-dimensional fabric space-time. Imagine space-time as a giant stretchy sheet. Place a heavy object on it and the sheet curves. That's what massive objects do to space-time. They bend it, creating what we feel as gravity. But gravity doesn't just affect space, it affects time too. Time flows more slowly in strong gravitational fields. A clock on a massive star ticks slower than one in deep space. This effect is real and measured. GPS satellites must adjust their clocks because time runs faster for them than for us on Earth. There's another way to bend time speed. The faster you move, the slower you experience time. Imagine twins. One stays on Earth, the other travels near the speed of light. When the traveler returns, they're younger. This is time travel to the future, a one-way ticket. So, is time travel to the future possible? Yes. We're all moving into the future, but physics allows us to change the rate. If we could travel close to the speed of light, we could leap centuries into Earth's future. The engineering challenge is immense, but the laws of physics permit it. The universe has left the door to the future wide open. We see evidence in GPS satellites and particle accelerators where time slows for fast-moving particles. The path forward in time is there, waiting for us to build the vessel to travel it. The future is open to us, if we can solve the engineering. The laws of physics say yes. Time travel to the future is real. The universe allows it. The only question is, can we build the machine? The journey continues. Few films capture Einstein's ideas like Interstellar. The movie makes time dilation, the stretching of time near massive objects, central to its story. Astronauts orbit a supermassive black hole, Gargantua, where gravity warps time. Every hour near the black hole equals years for those far away. This isn't just fiction, it's real science. On the water planet, a few hours become 23 years for those left behind. The emotional impact is huge, and it's a direct result of relativity. Interstellar's scientific accuracy was guided by physicist Kip Thorne, ensuring the black hole and time effects were based on real equations. The film takes some creative leaps, like wormholes and tesseracts, but its core is grounded in physics. Interstellar bridges science and fiction, showing that the universe is already full of wonder. We don't need to break the laws of physics to tell mind-bending stories. Sometimes reality is stranger than fiction. The truth of the cosmos is awe-inspiring. Traveling to the future is possible, but what about the past? This is where things get tricky. Paradoxes arise, like the famous grandfather paradox. If you change the past, do you erase your own existence? Many physicists think the universe has built-in laws to prevent such paradoxes. The past may be fixed, a part of space-time we can't alter. Some theories suggest changing the past creates a new timeline, not altering your own. Einstein's equations don't forbid backward travel, but the required conditions, like wormholes, are purely theoretical and need exotic matter we've never seen. For now, the door to the past seems locked. The universe protects its own history. The past remains a place we can only visit in memory. So, where does this leave us? Time travel to the future is real, an engineering challenge, not a scientific impossibility. Travel to the past remains theoretical, tangled in paradoxes and unknown physics. Scientists are still searching for answers, exploring quantum mechanics in the quest for a unified theory. There's no consensus, some are skeptical, others remain open-minded. What seems impossible today might be reality tomorrow. The journey to understand time travel pushes the boundaries of knowledge. As we explore and dream, we're already on the greatest journey of all. Like, comment, subscribe, and share for more cosmic journeys. Before you go, I have a question for you. Where in the world are you watching this from? Let me know in the comments below. I love seeing how far our cosmic community reaches.